321. I'm John Miglosh with the Wisconsin Direct Marketing Association. Today I want to cover the history of computers in marketing and how we got to this AI buzzword and machine learning and all that, and how it works, why it works for some, and it mainly does not work for others. Okay, so back in the day when I got started in direct marketing, I highly recommend Claude Hopkins' book, scientificadvertising.com. You can get the book for free. Written 100 years ago, and he explains that in direct mail, we were able to mail different lists. Okay, so we had different lists, and we would label the lists. Okay, we would label the lists, and so we would rent Land's End, or we might rent LL Bean, or we might rent more business products, and based on how they performed, we would keep very careful track. Some people even coding the part numbers so that they could track it back to the individual list or drop. And we would keep very careful track, and from that we would discern what our customers were like and which offers did the best. Okay, and this had been in place for 50 years before Claude Hopkins. Okay, we were able to do that just by tally sheets. Okay, but then along came computers, and I was actually at the New York Hilton in the early 80s, and I said I want to hook up my computer to the presentation, to the TVs or something. And they said, no one's ever done that here. Why would you want to hook a computer up for a presentation? Think about that. I said, well, I'm talking about how computers might apply to marketing and how we're using them. And they said, okay, we'll do it. And in the room, no one was somebody called, but I can't see who. No one was using a computer in there, including LL Bean. They had one, and that was about it. Okay, so what happened was, because of that, I started getting calls from big companies. We started mainly with the Hudson Bay Company, and we said they wanted a marketing database that they could understand and that they could do a model for their best customers. But the thing is, they were offering travel packages, they were offering insurance, offering all sorts of things. And I said, what you really want is you want a tool that builds models. This was decades ahead. This is where we're finally getting to now in the rest of the world, where we do not just one model, but we do a model for each offer. And the IT people were mad because I had changed the spec and all this stuff. But anyway, the marketing people were delighted. So, we decomposed the Prism clusters and found postal code variables. So a variable, let's think about a variable. Okay, remember the mailing list example. Okay, now what we were able to do was take our customer file. Okay, here's our customer file. And we were able to make each little component a list. Okay, and each list was made up of a bunch of different variables. So each customer segment was somewhat unique. Got it? Okay. Now, one problem was now we had dozens of variables. How do you keep that straight? And for that, we used SPSS Shade. Thank you, Connie Bauer at Marquette. And we would figure out which customers fit in which segments and which descriptions. And we were so excited because we said, oh, the people who buy the travel packages all have high credit limits. And we told John and Nancy, and they said, almost. But the truth is, if they're interested in the travel package, we look at their credit limit, and if it's not big enough to buy one, we raise it. It was circular. So then we realized that we had to have time involved. We rebuilt the database so it would move back and forth in time, and we could make it look like before we ran the promotion, and we could see the results. And that allowed us to build a dependent variable. And this in AI is a training set. We were able to build a training set, a labeled data set. This is the biggest problem with AI. The biggest problem is people don't have a training set. Now, they do in self-driving cars. It's interesting because I actually met someone who'd been working on computer understanding language. They'd been working on it for 17 years, and it really wasn't any good. And I used to try it every now and then. I'd buy a copy of Dragon Naturally Speaking or something. And I said to him, were you frustrated that Google just smoked you? All of a sudden, Bing? He said, no. He said what Google had was they had the best data set. They had a better dependent variable. You know what Google did? It's very smart. What Google did was they took the corrections. They kept track when they recorded your words, and then you came in and fixed them. And that's how they knew they were making mistakes. The computer could learn because the computer could identify the mistakes. And it's all about that ability. The problem that Watson's having with the medical community is there are no clear right and wrong answers. It's not like Jeopardy. The world is not like Jeopardy. But after the Hudson Bay, we learned that we could roll the database back in time. We could then have hundreds of variables. Now we average about 400 variables per client, just like that when we start out. And we can see which variables mattered on a map, on a 3-page map or something you put on your desk. A 3-page map, we can see the value of each variable. Okay, so that's the way we use machine learning. What we do is first we work very hard on the dependent variable, on the labeled data set. So in self-driving cars, they take pictures of bus, car, bicycle, pedestrian, and they show the computer thousands or millions of pictures. And the computer starts to get, probably builds its own parameters. Now the problem with that is, well, back to the dependent variable. So the dependent variable we build, first we did they buy or didn't they? So we would take our customers and we'd divide them up by RFM, and we'd say these have bought twice, these have bought 10 times, these have bought lately, these didn't, these bought a lot, these bought a little. Okay, we use that. That's pretty easy to understand. You can build an algorithm. But it's not the variables. It doesn't give you the insight. So then we took the dependent variable and said, well, let's go all the way to profitability. Let's take profitability and rank the results. Remember the results after we mailed them. And we use mail because you have to deal with it. When it comes to your mailbox, you have to read it, you have to put it in the trash or not. Okay? Digital, mass media, you don't know if people are watching or not. I mean, some are watching because you get some results. But in mail, you are invasive. You force engagement. So the machine has more to work with. We have a much better dependent variable. We can take it all the way to profitability on each order. Okay? So here are the tests now for the variables. Okay? So first we have a good dependent variable. It's rare in marketing that you have a good dependent variable. And this is the problem. This is why AI is failing in so many marketing cases. Because they take big data from Twitter and from all these other places, and they have millions and millions of lines of data, but they don't have a dependent variable. They don't know what they're looking for. They don't have anything to correlate against. Okay, then we take that dependent variable, first test, and we let the machine play with it. The machine sorts out from the hundreds of variables, the machine boils it down to maybe 40 that matter. Okay, maybe 100 that matter at any given place in the model. Then we get this old guy who has done this for 25 years, and he sorts out whether or not what the machine finds makes any sense. Okay, so we've got the dependent variable, we've got the machine doing the model, then we've got the guy running the machine saying, yeah, the percentage of disabled people over 85 per postal code, that's not going to be a strong variable. The percentage of mobile homes as housing units is probably not going to be strong. He throws those away, okay? The fourth test is we take a particular campaign, if we've rolled it back, we split it in two, and then we take the model and put it on top of the holdout sample, the other half of the mailing. And we see if the variables work the same in that validation as they do in the model. We see if the machine got it right or the guy got it right, and we throw out more variables. And we find the ones that work, make the test, make the validation, and work in the validation. And then we have a fifth test, and that is we put it in the mail. So Musician's Friend tested us 11 times over 6 years with 8 different modeling companies. We won them all. We beat the UCLA statistics department by 321% on a unique test. They said we must have cheated. No, we didn't cheat. Anyway, and so instead of testing against us, they did what's called a backtest. And in a backtest, a modeler just lets the machine play. And the machine got just as good a value out of the model as we had. The difference is ours had already gone through those 5 tests, or 4 of the 5. And so, well, yeah, all 5. And so what looked good to the machine when they mailed it, I got a call about a year later, and one of the consultants said, "Did they test against you? Because their results have gone to garbage since you left." That's because they didn't test the variables. They let the machine do all the work. I hope this has been enlightening. I'm John Miglosh. Like and share.